Today we're going to be talking about equivalent fractions. Equivalent fractions are fractions that name the same amount. Take a look at the models on the paper. You will notice that in the case of each of the three models, the exact same fractional amount is shaded. In the case of the first one, we have 1 out of 2 equal parts shaded. That's why we call that 1/2. In the case of the second model, the exact same amount is shaded, but now the total number of sections is 4, and 2 out of the 4 are shaded. 1/2 is equal to 2/4 because the exact same amount is shaded. Now we just have more sections, but the same amount is shaded. 2 are shaded out of 4, 1 is shaded out of 2. You see the same process with model 3 and 4. In the case of model 3, 3 out of the 6 equal sections are shaded, and in the fourth model, 4 out of the 8 equal sections are shaded. But these are all equivalent or equal fractions because the exact same amount is shaded. These are just different names, different fractional names for the exact same amount shaded. But what if you have to write an equivalent fraction without the use of a model, without being able to visually see and count? Well, in order to understand how to write equivalent fractions without the model, you first have to understand the identity property. The identity property of multiplication states that any number multiplied by 1 equals the original number. So, taking for an example, whole numbers, 52. 52 times 1 equals 52. You start with the original number being 52, you multiply by 1, you get the original number, 52. Works for decimals, 8/10 times 1 equals 8/10. Anything you multiply by 1 whole equals the original number. That's the identity property of 1. Same thing will work for fractions. Take a fraction, for instance, 2/7. 2/7 times 1 equals 2/7. We're going to use that idea today to write equivalent fractions. So if I have a fraction 2/7, I want to get another fraction that's equal to 2/7. All I have to do is multiply by 1 whole. But we're going to do that in a little bit different way. Instead of multiplying and showing us multiplying it by 1 whole by writing the whole number 1, we're going to look at 1 whole in the fraction form. So I'm going to multiply 2/7. I'm still going to multiply it by 1 whole because I want to get a fraction that's equal to 2/7. I'm still going to multiply 2/7 by 1 whole, but instead of calling it 1 whole and writing 2/7 over here, I'm going to call it by one of its fractional names, like 3/3. Let's take a look at 3/3. If I had a rectangle, divided it into 3 equal sections, which, as the denominator is indicating, 3 equal sections, and I shaded all 3 sections, I have shaded 1 whole. So 3/3 is equal to 1 whole. So multiplying 2/7 by 3/3 is the same as multiplying it by 1 whole. So 2 times 3 is 6. 7 times 3 is 21. So I've created a fraction that is equivalent or equal to 2/7, but I've given it a new name. So 2/7 is equal to 6/21, or 6/21. They are equivalent fraction because all I've done is multiply by 1 whole. I've just called that 1 whole by its fraction name, which is 3/3. Well, what other fractions equal 1 whole? I'm going to go back to the 2/7 again and multiply it by, say, 5/5. 5/5 is equal to 1 whole. Again, picture a rectangle, divide it into 5 equal sections, and you shade all 5 sections. That's 1 whole. 2 times 5 is 10. 7 times 5 is 35. So 2/7 is equal to 10/35 because all I've done is multiplied by 1 whole, otherwise known as 5/5. All right, you could essentially multiply by anything as long as the denominator and the numerator are the same. Take something crazy like 10,000 10,000ths. If I multiplied 2/7 times 10,000 10,000ths, which again is equal to 1 whole, I'm going to get a fraction that still equals 2/7, but this time the fraction is going to be called 20,000 70,000ths. 20,000 over 70,000 is equal to 2/7. So now if I gather all these fractions and write them to the bottom, you'll see that 2/7, my original fraction, is equal to 6/21, which is equal to 10/35, which is equal to 20,000 70,000ths. Those are all equivalent fractions. They all name the exact same amount. They just have different names. Okay, now that we have that, and now that we know we can multiply by any fraction equivalent to 1, meaning our numerator has to equal our denominator, what if our choices are a little bit more limited? Like this. In this case, you'll see 4/5. We want to create a fraction that's equal to 4/5, but it has to have 20 in the denominator. This time we can't pick anything we want, like 3/3 or 5/5 or 10,000 10,000ths. We know it still has to equal 1, but we want to pick the specific fraction that's going to give us 20 in the denominator. So we ask 5 times what number equals 20? The answer is 4. Well, in order to build a fraction that's equal to 1 whole, I have to put a 4 on the top because 4/4 is what's equal to 1 whole. So now I've got 4 times 4 to create the missing numerator, 16. So 4/5 is equal to 16/20. These two fractions are equivalent because all I did is multiply 4/5 by 1. And the reason I chose 4/4 to do that is because the denominator in the bottom had to be 20. And 5 times 4 equals 20. All right, let's look at problem B. Same process, except for this time they've given us a numerator. 3/10 times what? Remember, this has to equal 1 whole. Equals 12 with a missing denominator. Well, I know 3 times 4 is 12. So whatever I put in the numerator, I have to put in the denominator because this has to equal 1 whole. And 4/4 is equal to 1 whole. So in this case, 10 times 4 is 40. 3/10 is equal to 12/40. These two fractions are equivalent. They are equal because all I've done is multiply by 1 whole. All right, in these, you will see that the same process is going on, except for this time the numerator is missing in the first fraction. So we have to kind of look ahead and we have to say 11 times what number gives me 33? Well, I know that's 3. And once again, this middle fraction has to equal 1 for the identity property. So now I have to ask myself, what would the numerator be? Well, the numerator would be 3. Because in order to equal 1 whole, it has to be 3/3. So you ask, what number times 3 equals 27? Well, here you have to use the inverse property and divide. 27 divided by 3 is 9. So 9 times 3 is 27. So my missing numerator in this case is 9/11. So 9/11 is equal to 27/33, or 27/33. And lastly, same thing here, except for this time, my denominator in the first fraction is missing. Same process. 1 times what number gives me 3? We know that's 3. In order for this to equal 1 whole, I have to multiply by 3/3. 1 times 3 is 3, so you ask yourself, what number times 3 equals 36? Well, I know that 12 times 3 is 36. And to get there directly, I would do 36 divided by 3 and know that that answer is 12. So I've created an equivalent fraction of 1/12. 1/12 is equal to 3/36 because all I've done is multiply by 3/3 or 1 whole. Going back to our original problem with the models, now we see with the models that all of these are equivalent, but let's now use that shortcut that we've learned, the whole idea of the identity property, and make sure this works. 1 times what number gives you 2? Well, we know it's 1 times 2. And in order to multiply by 1 whole, it has to be 2 halves. So 2 times 2 is 4. So without even the model, we know we can multiply 1/2 times 2 halves and get 2/4. Well, now when you try to build on here, you might be thinking, 2 times what gives me 3? There are times when you have to go back to your original fraction. So let's pull that original fraction down and write it right here, 1/2. And let's set him up to be equivalent to 3/6 and check it and make sure the multiplying by 1 identity property is working here. 1 times 3 is 3. So I have to multiply by 3/3. 2 times 3 is 6. So yes, indeed, it does work. 1/2 is equal to 3/6. So we know 1/2 is equal to 2/4, and 1/2 is equal to 3/6. So therefore, all three of these are equal. Once again, we can't build off of the 3/6 to equal the 4/8, because 3 times what gives me 4? Well, that's not a whole number. So let's bring down the 1/2 again for this guy. 1/2 equals 4/8. 1 times 4 is 4. 2 times 4 is 8. So 1/2 does equal 4/8. 1/2 equals 4/8. 1/2 equals 2/4. 1/2 equals 3/6. So therefore, you see it in the model, and you see it by multiplying by 1. They are all equivalent. Now you try the equivalent fraction skill on your own. Good luck.